Sup, good people? This is Trockers. Welcome back to my channel. Okay, today we are focusing on parametric differentiation. Yes, I mean it, parametric differentiation. What is parametric differentiation? It is simply differentiation that is carried out on parametric equations. As we can see, both x and y are expressed in terms of t. So we want to find dy dx here, but what we are going to do first is to differentiate x with respect to t, and we get our dx dt, and we get our dx dt. Then we differentiate y with respect to t, and we get our dy dt. Then we apply the chain rule so that we have dy dx is equal to dy dt divided by dx dt. Then we will simplify, right? So according to this problem, we are given those two parametric equations, and we want to show that the derivative is equal to tan of 2t plus pi over 4. Okay, now I need the whiteboard here. Okay, so allow me to write the equations down. I need these two equations: x equal to e to the 2t cosine of 2t, then y equal to e to the 2t sine of 2t. Right. Okay. Then our x is equal to e to the 2t cosine of 2t. So here, guys, you need to think of the product rule, right? So y is equal to uv. When you differentiate, you just say u dv plus v du. And also, you need to think about how we differentiate cosine and how we differentiate sine. Okay, so to get my dx dt here, I just say this is my u and that's my v. So it's u. And if we differentiate cos, we get negative 2 sine 2t plus my v, it's cosine of 2t. Then if we differentiate this, it's 2e to the 2t, right? So when we simplify, it's negative 2e to the 2t sine of 2t plus 2e to the 2t cosine of 2t, which can be further simplified to 2e to the 2t. Then we have cosine of 2t minus sine of 2t, right? So this is what that's what we have here. So I can put it down. I know my dx dt is 2e to the 2t over cosine 2t minus sine of 2t, right? Okay, now I will do the same. Y equal to e to the 2t sine of 2t. We do the same. To differentiate y with respect to t, we're going to get u dv. Here is 2 cosine 2t plus v. If we differentiate this, is 2e to the 2t. So the answer will be 2e to the 2t cosine of 2t plus 2e to the 2t sine of 2t, which can be further simplified to this, right? This is cos 2t plus sine 2t. So now let me write it here. So my y prime is 2e to the 2t, then cosine of 2t plus sine of 2t. Good. Then from here, okay, let me get rid of this. Let me get rid of this. Okay, time to sip some water here. Okay, now let's proceed. Remember, we are going to use the chain rule. Dy dx is equal to dy dt divided by dx dt. So it's equal to 2e to the 2t over cosine of 2t plus sine of 2t divided by 2e to the 2t cosine of 2t minus sine of 2t, right? And this and that will cancel out, right? So here, here we remain with cosine of 2t, okay, we remain with cosine of 2t plus sine of 2t over cosine of 2t minus sine of 2t. So from this stage, guys, there are several methods which you can use. It's either you can use the formula for expanding tan A plus B, but I'm not going to use that method, and I'm not saying that method is wrong. No, it's still valid, but I want to explicitly arrive to the desired outcome. So I'm going to use the RCOS method, right? So what I'm going to do is, remember, if you come back to the question, right, the end goal is to have tan. Then I know that when I'm dealing with sine and cosine, we know this identity that tan x is equal to sine x over cosine of x. So I need sine to be the numerator and cosine to be the top. So what I'll do is I'm going to let this here cosine of 2t plus sine 2t be identical to r, then sine 2t plus alpha. So when I expand the right hand side, I'll get r sine 2t cos alpha plus r cos 2t sine alpha. Then if I'm to compare for cosine, which is this one, I'm seeing that r sine alpha equal to 1 here. Then I'll do the same. So sine alpha is 1 over r. Then here r cos alpha, because if I'm to compare the coefficient of sine 2t here, is equal to 1. So cos alpha is equal to 1 over r. So I'll have my right triangle here with my alpha. So sine is opposite of hypotenuse, cos is adjacent of hypotenuse. To get r, I can apply the Pythagorean theorem. So r squared is equal to 1 squared plus 1 squared. So r is just square root of 2. Then I can use the trigonometric ratios here. Tan alpha is opposite over that is 1. So alpha will be 45 degrees, which is just pi over 4. So we see that the top part now becomes my r, which is square root of 2. Okay, let me use this one. Okay, so it's equal to my r, it's square root of 2. Then sine, then it's 2t plus my alpha is pi over 4. Right, then I'll do the same. I'll do the same here for the bottom. But remember what I said, for the bottom, we need cos. So if it's negative, we can expand cos. So we can let here cosine of 2t minus sine of 2t be identical to r cos 2t plus alpha, because we know that when you expand this, it's r cos 2t cos alpha plus r sine 2t sine alpha. Then if you compare here, I'm going to get the same thing. R cos alpha is equal to 1. So here cos alpha is equal to 1 over r. Then if you compare the r sine alpha is equal to 1, sine alpha is equal to 1 over r. So remember, if we have this triangle here, 1, 1, r, like what we got last time, it means my r is equal to root of 2 and my alpha is pi over 4. So we come here and we say square root of 2 cosine 2t plus pi over 4. So when we cancel out this and that, right, we remain with sine over cos, which is equal to tan 2t plus pi over 4 as required, right? So we have shown what is needed. Remember, we are supposed to show that dy dx is equals to tan 2t plus pi over 4, which is exactly what we have here. This is exactly what we have here. So guys, remember, when you are dealing with parametric equations, first you differentiate one variable with respect to the parameter, then you do the second variable with respect to the parameter. With that being said, it's now my time to sign out. Later.